Okay, so our example is a plane 2 miles above the ground is flying horizontally. That means the plane is say here. So it, and from the ground it is, what is the height? It is given 500 meter per second, and this is given in miles. So we should convert miles to kilometer or meter. We'll do that. First let us see the problem. So it is going that way and threw a bomb. Now at the beginning when it threw a bomb, whatever the velocity of the plane, that was the velocity of the bomb also. So in aeroplane, when we travel in aeroplane, we are sitting, we are enjoying movie, we are drinking, but our speed is not zero. You think that, oh, I am just relaxing, resting, but actually no, your speed is very high. You cannot feel that. Okay, you just see the relative speed compared to your neighbor. Your neighbor is sitting and you are sitting close to your neighbor. Your distance is not changing, so you are thinking you are sitting at rest, but every moment you are moving. In fact, in this world, our world is moving, rotating, so we are not at rest, but relatively we are at rest. So at the beginning the velocity of the bomb is also 500. It was not at rest, so do not make this mistake that a bomb is released from the aeroplane, that means the initial velocity is zero. Never. It is the speed of the aeroplane. When the bomb will go out of the aeroplane, then the bomb will feel that it had a speed. Maybe I am talking so much. Okay, so 500 meter per second is our initial velocity. It is horizontal. Okay, then, oh, question is what is the time? So it will go this way. Question is what is the time? We'll find it. Okay, before finding, make the unit consistent. This is given meter per second. I need to convert it into meter. So we know 1 miles equals 1.6 on kilometer, and 1 kilometer equals 1000 meter. So if you do that, we will get the total height. Now you do not need to memorize it. This conversion is in your book, or you can use Google, whatever. I found 3220 meter. That is our height. Now we need to find t. We know our vertical velocity here was 0, but we do not know the velocity here. Now how to find it? Different way. So what are the okay, let me make it bigger or understand the question. So question is the what is the time, and then question is what is the x, the horizontal distance. Now no need to memorize it. In fact, whatever method I did in my handout may be different than what I am solving now. So it's all about understanding the work. Say for example, if you have a driving license, if you want to go to Denver, you do not need to memorize that. How will you go? Just go to the road, then you will find out the way to go. Similar way. Now, what are my equation? We know our equation is say one equation say Vy equals Vy naught minus Gt. We know this equation. Or say plus now. Discard the sign. We will talk about sign later. Other equation say A is equals V naught 0 t plus half gt square. Other equation, there are a lot of different equation. In x direction, if I say in x direction is vx naught times t plus half a t square. In x naught direction this value is 0. In x direction this value is 0. Okay, now what I was telling, I forgot actually. Oh, now my question is I need to find my time. We can find it in a single action, or we may need it in multiple action. So in this theory, we have another equation. Vy naught square equals Vy naught square plus 2iz. Now here I wrote this equation in y. Any of this equation will fit or no? Then we will think about it. First one, Vy. We know Vy naught is 0. But do we know Vy somewhere here? No, we do not know. That means this equation is not applicable. Second equation, A is height. Do you know? Yes, we know height. Vy not. Do you know? Yes, it is 0 because plane was moving horizontally. There was no vertical speed. So this portion is 0. Do you know T? Wait, we need to find T. Do you know G? Yes, we know. So this equation can help us. Okay, still though I'm exploring more. X, do we know X? No, we do not know X. We know this true, but we do not know this. So this equation will not help me right now. As we do not know Vy, this one will also not help us. So we will use this equation. So this is the way to solve the dynamics problem. Equations are in your book. List the data given and then list the equation you know, or open your book, then find which one will solve your problem. So A's, this one we know it. Okay, what is A's? Now, in this equation, let us assume down A is positive. Down A is positive. So A is how much? 3220 meter. Down A positive. This portion is 0, 0, half G. What is G? 9.81 because it is in meter per second square equation. T is time. Then you can find it. What is your time? So 3220.
I think it's T squared.
Oh yes, T square. Thank you, thank you. T square. That means so this will be 3. Oh, that means somebody is actually following square root. I got 25.6. After 25.6 second, the bomb will reach to ground. Now here solution is not the important. Important is how to solve, and hopefully I explain how to solve. Just list whatever the data given, then explore your equation. What I did one by one. Yes, you need to write. It is better if you write down your equation. Then what will happen? You will automatically memorize it, and that will go to your brain quickly. If you just open the book and think about it, then it will be typical. See, every time I write the equation. Although I know in this problem what equation to use at the beginning. I know this is my equation because I solved this problem earlier. But again, though, I wrote it here to show you. Okay, so time is done. Then the question is asking what is x. Now how to find it? You can see here the x only one equation, this equation. As I know my time, I know my Vx naught. Now Vx naught is the initial velocity. My Vx naught will never change for a projectile. So this will be 500 meter per second. Time will be 25.62 second, whatever it is. Now in your exam, do not solve this way. Then when I will see from the top, and I will see where you got this time. You did it. I write somewhere in the below that I can follow it. As I have no space here, so I am doing it here. Okay, then what about that distance will be? That will be the distance. Hopefully you understood this problem. Okay, let us see one more or check the answer from your book. So if I see, yes, so whatever we did in the example, I did the same thing. Now let us see one more example, this example. Okay, before erasing this slide, this work, make sure you wrote it down. If you did not, I am pausing 2-3 seconds. Okay, maybe now is a good time. So next, okay, make it this example. A fighter plane while moving horizontally, a similar problem at a height of 480 meters. That means very close to the ground. Was only 480 meter. very here it's small, and with a speed of 147. So its speed is 147 meter per second. Slowly dropped a bomb. Again bomb. Okay, dropped a bomb. Avoiding the air resistance, calculate the velocity of the bomb after 5 seconds. That means the bomb will come somewhere. Say after 5 seconds it is here. 5 seconds. What is the velocity here? That is the question. Okay, so we know all the data. What is the velocity after 5 seconds? Yes, so at any point of this path, it has two velocity. One is Vx, one is Vy. And there is the direction is one is this way, other is this way. And we know from similar angle triangle that if two values is this, their um, resultant will be this way, and we can find this resultant using Vx square by square twice Vx by cosine 90. Cosine 90 is 0, so this portion vanish. So V equals this. Or you can memorize this. Whenever there are two components perpendicular, to find their resultant, we simply take their sum of the square and then square root. Now why square root? I just showed the equation here. It was the parallelogram equation that you saw somewhere in your statics class. That time the equation was this: r square was p square q square twice pq cosine alpha. That time we wrote the equation in that format. Now we are writing bx b naught by 2 bx by cosine 90 because their angle was 90 at the beginning, if it is perpendicular. Okay, long story short, so we need to find the speed. To find speed, I need both component. Now what is v naught? Bx, we know that bx is always constant. V naught 147 meter per second. One is known. What is Vy? Now which equation to use? Our first equation are Vy naught plus Gt. Even I do not need to go more. My first equation will give me answer because see, time is known 5 seconds. Z is known 9.81. B not known because it was going horizontal. B not was 0. So I can find my Vy 9.81 meter per second. T is 5 seconds. I don't know how much. 5 9. Oh, if it's 10 98 say 49. A calculator. I should not pressurize my brain. Yes, 49.05 meter per second. Then we can find our velocity. Whatever it is, 147. This is 49.05. Whatever it is, it is. Now, this problem example is important because it is a little different from other problem. Other problem was just find time, find horizontal range, find height. This time it is different, find speed at any point. And in FE exam, very important. And do not forget the two components. This is a curved path. At any point, it has two components of velocity. I was thinking something. Oh, for some reason, well, I was thinking, but I forgot. Oh, for this problem, there is a risk. The risk is that if I tell here what is the velocity after say 200 seconds, if I give a very big number, I think I did not check this in my handout too, but I should check it. What is that? We should check whether at that time my particle is on the air. If my time is such that it is already in the ground, If it is already in the ground, then it will not, its velocity will be zero, because it will hit on the ground, and then after hitting it will stop. So we should check that also. In my handout also, I cannot remember whether I checked it or no, but I should check it. Let me see what I did. Yes, I did not check it. We should check it. Maybe you understood what I mean. I mean that if in this 5 second, if the particle already comes to the ground, then its velocity will be zero. It will stop. So we should check that in 5 seconds, it did not come to the ground. So we should check. So that checking I am doing here. What is the check? Well, like to confirm this height was given. So we'll find our height after 5 seconds. So a is equals v naught y t plus half g t square. Initial velocity was 0, so it is 0. Half g is 9.8 on, t is 5 square. Right here 0. What is the height? 0.5, 9.8 on time 25 square. So 5 square. So it is on 22. That means my height is 480. I got 100. That means after 5 seconds, it will actually come. It will go this height. So our problem is right. Whatever we solved is right. This is kind of check, or you can do it at the beginning. So make sure that you understood what I mean. This portion is extra, but it is very important. And otherwise, if you do not check it, and if you find that after 5 seconds the particle is already in the ground, then all of your work you do not need it. You can just simply tell that as the particle already reached the ground and it will stop, so velocity will be zero. Okay, let me. I'm right. Okay, I will stop here.